Hello there, students and friends. As part of our Back to Basic lecture series, here's another commonly misunderstood concepts in kinematics, velocity, and speed. So join me till the end of this video to see how velocity differs from speed. Our question number one, which is about average velocity of a cyclist. Five cyclists, A, B, C, D, and E, each take a trip that lasts 30 minutes. The positive x direction is to the east. Number 1, cyclist A travels 5 kilometers due east. Number 2, cyclist B travels 5 kilometers due west. Number 3, cyclist C travels 6 kilometers due east, then turns around and travels 1 kilometer due west. Number 4, cyclist D travels 7 kilometers due east. Number 5, cyclist E travels 2 kilometers due west, then turns around and travels 2 kilometers due east. Question letter A. Rank the 5 trips in order of average x velocity from the most positive to the most negative. Question letter B. Which trips, if any, have the same average x velocity? And question letter C. For which trip, if any, is the average x velocity equal to 0? So our solution, these are the data given in the problem. All right. Cyclist A has its displacement represented by delta x equal to 5 kilometers directed eastward. While cyclist B, its displacement is equal to 5 kilometers due west. Cyclist C has its displacement first displacement number 1, which is 6 kilometers due east, and then he turns around and move 1 kilometers westward. So for a total displacement equal to 5 kilometers east. Now cyclist D, his displacement is 7 kilometers due east, while cyclist E, first his displacement is 2 kilometers westward, then he turns around and moves 2 kilometers eastward. All right, for a total displacement equal to 0. We also emphasize that the positive x direction is going eastward, and that each cyclist, all right, took a trip of delta t equal to 30 minutes or half an hour. So we first have the average x velocity, all right, for each cyclist, starting with cyclist A, and average x velocity is just determined by dividing the total displacement delta x, all right, by the time elapsed delta t. And for cyclist A, that is positive 5 kilometers divided by 0.5 hour. 30 minutes is converted into 0.5 hours, so that cyclist A has an average x velocity equal to positive 10 kilometers per hour. All right. Now, moving on to cyclist B, using the same formula, All right. Uh, the displacement of cyclist B equal to negative 5 kilometers, right? And that is divided by the delta t of 0.5 hour. So, cyclist B's average x velocity is equal to negative 10 kilometers per hour. For cyclist C, again using the same formula, all right, his displacement is positive 5 kilometers, again divided by 0.5 hour. Therefore, cyclist C's average x velocity is equal to positive 10 kilometers per hour. So, continuing with our computation, for cyclist D, his average x velocity using the same formula, once again, delta x over delta t, all right, or positive 7 kilometers divided by 0.5 hour. So his average x velocity, this is cyclist D, it is equal to positive 14 kilometers per hour. All right. And finally, for cyclist E, all right, his total displacement is 0 or 0 kilometer. So divided by the time elapsed, 0.5 hour, his average x displacement is equal to 0 kilometer per hour. So, answering question letter A, which requires us to rank the trips in order of average x velocity from the most positive to the most negative. All right. Our answer is D, A, and C, and B. Right. So, we say that the average x velocity for cyclist D is the most positive, which is equal to positive 14 kilometers per hour. That of cyclist A is the same with cyclist C equal to positive 10 kilometers per hour. And the most negative is that of cyclist B, which is only negative 10 kilometers per hour. We have those um, values for computed average x velocities in our previous slide. Now, for question letter B, which is asking for the trips that have the same average x velocity, all right? And our answer, all right, our answer, of course, is uh, cyclist A and cyclist C, all right? So both cyclists have the same average x velocity equal to positive 10 kilometers per hour. And finally, for question letter C, which trip or for which trip is the average velocity equal to 0? All right. And our answer, of course, is cyclist E, which, according to our computation, all right, since his average, I mean, its total displacement is 0, so automatically his average x velocity is also equal to 0, or 0 kilometers per hour. I hope you were able to see the difference between average, positive average velocity and negative average velocity. In the next question, question number 2, you will also be able to see the difference between positive instantaneous velocity and negative instantaneous velocity based on a displacement time graph. And likewise, you'll be able to see the difference between instantaneous speed and instantaneous velocity. So the question is, the figure shows a displacement time graph or xt graph of the motion of a particle. Question letter A, rank the values of the particle's x velocity at points P, Q, R, and S from most positive to the most negative. Question letter B, at which points is the instantaneous velocity positive? And at question letter C, at which point or points is the instantaneous velocity considered negative? Question letter D, at which points is the instantaneous velocity equal to 0? And lastly, question letter E, you're going to rank the values of the particle's speed, all right, or instantaneous speed at points P, Q, R, and S from the fastest to the slowest. All right, so for our answers to this question number 2, first, uh, let's emphasize that the x velocity being described at each point in the graph is actually referring to the instantaneous velocity, all right, and not the average velocity. So for any displacement time graph, the x velocity is positive when the slope of the graph is positive, such as at point P in this graph. All right? It is negative when the slope is negative, like at point R in the graph. So point P, we say that the instantaneous velocity is positive because the slope of this line is positive. All right? And at point R, the Vx is negative because the slope is negative. All right, notice that the curve between points P and Q, all right, this curve between points P and Q, it seems to get less steeper as time increases. All right, so this curve becomes less steeper, especially as it reaches point Q. All right, and we say that the slope of the line, all right, the slope of the line that is tangent to point Q, if you're going to draw a line tangent to point Q, it's going to be a horizontal line, all right, a horizontal line, and the slope of a horizontal line is of course equal to 0, all right, and that slope of the horizontal line suggests that the instantaneous velocity at point Q is 0. All right. Now, likewise, at point S, all right, at point S, the line tangent to that point S is also a horizontal line, all right, a horizontal line whose slope is also equal to 0. And therefore, we say that the velocity at point S must also be equal to 0. All right. By the way, when we say a line tangent, it is the only line that touches the point such as point Q. There's only one and only one line tangent to that point. Likewise, there's only one line that is tangent to that point S. Alright? So we are in fact describing the instantaneous velocity at point Q as well as at point S. Now, moving on to our answer to letter A, which is asking us to rank, alright? Rank the points from the most positive to the most negative instantaneous velocity. And our answer is, the most positive is of course point P, then point Q, and S actually are tied, alright? And the most negative is at point R. So that's our answer to question letter A. Likewise, for question letter B, which is asking for the positive velocity, alright? So we say that the instantaneous velocity Vx is positive at that point P. Again, the reason is that the slope, okay, of this line where point P is lying, alright, is a positive slope, and hence the slope of that line represents a positive velocity. And when you're talking at point P, you are referring to the instantaneous velocity at point P, which must be positive. And for question letter C, which point has the negative velocity? Of course, our answer is at point R. So, the instantaneous velocity Vx is negative at point R. Again, the reason is that, alright, the line that is sloping downward, alright, downward to the right, including at point R, alright, the value of that slope will come out to be negative. And hence, the instantaneous velocity at point R means it is negative. Alright? And what about question letter D? Alright, question letter D is asking for the points where the instantaneous velocity is equal to 0, and we already answered that earlier, which is at point Q as well as at point S. Those points, the instantaneous velocity is equal to 0. Alright? And we already explained that it is because the line that is tangent to each point Q and S is a horizontal line whose slope is in fact equal to 0, which suggests that the instantaneous velocity Vx is equal to 0. Alright? So, we have now the final question, which is asking for the ranking of the points according to the fastest speed to the lowest speed. Alright? So, how did we get the answer? Our answer here is fastest speed is at point R, followed by point P, and then Q and S, alright, have the slowest speed, which we know the speed at each of these points, Q and S, is also equal to 0. Alright? But why is the speed at point R greater than at point P? Alright? Remember that speed only has a magnitude. Alright? It has no direction. So we disregard the direction of the instantaneous velocity since we're only asked to rank the speed according to the fastest to the slowest. All right. We say that the speed at point R, all right, represents, a faster speed compared to point R, point P. The reason is that, all right, the slope where the point R is located, all right, the straight line sloping downward is steeper, all right, it is steeper than the line where point P lies, all right. So the steeper the line, the greater its slope. And the value of the slope of a line, all right, regardless whether it is uh, sloping downward to the right or sloping upward to the right, doesn't matter. We are only talking about the absolute value of the slope, all right, which represents the speed. And that's how we are able to conclude that the speed of the body is faster at point R compared to the speed at point P. All right, so we are done with our tutorial. Thank you very much for your indulgence. Till the next episode, inshallah. Thank you very much for watching. Please follow me in my FB page and please don't forget to subscribe to my YouTube channel.